So this video is, it's a bit of a long one, so tap on the screen, see if you've got that kind of time, otherwise save it to watch later and come back. This also is expecting that you have some type of knowledge, not necessarily expertise. It could have been, you know, an old obsolete program like Fortran that you worked on back in the 80s. That's fine. I am expecting that you have a little bit of a knowledge of the basics of programming in general. Don't need any knowledge with Java itself. Just the concept of writing a program is very helpful. So if you're not familiar with that, I would put this in watch later. Go into my channel home. I've got a bunch of other basics of programming type videos all through there. And yeah, take a look. See about other stuff. Get up to speed here with just the general concept of programming. Once you kind of get the idea down, don't need to be an expert in any language. This is also very basic, so if you're already a Java expert, I've got other programming tutorials that you might decide to switch a language. That'll probably be a better use of your time. So here we go with, first of all, I'd like to tell a bit of a story. And yes, it's a story as in fictional. There was this guy, you know, one of your run-of-the-mill bosses, and he decides that he wants to produce an Android application. Now, Android applications is one of the big things that we use Java for. There's a bunch of stuff we can use it for. We can use it for you know, for command line interface stuff, which is what a lot of this is about. It's just teaching a lot about the basics of that. But when you get further into it, you can deal with GUI applications, you can deal with web page applets, and one of the big ones these days has been Android applications. There's like 4 big languages that are heavily used in that area. Actually, there's 2 of them that are really big, and that's Java, which has been around the longest and it has probably the best libraries. There's also Kotlin that's been around, at least for a few years now. And then there's also C and C++, and I think PHP is working on getting into it as well. There's some other languages as well, but Java is the key one. I would say if I was going to write an app, I would still use Java, just because it's been there. Anyway, so this guy decides he wants to build an Android app, application, Android app, they call them. And so he gets an office with 20 computers in there, and he's your average run-of-the-mill corporate America cost cutter, and looks at the price of real programmers and figures he's going to cut the cost and he'll hire just whoever he wants. So he hires the people in there and brings them in and tells them, let's pour on the Java. He means let's get to work, and he means, yeah, he needs them to get into some Java coding, but they don't even know what Java is in the sense of what we're talking about on this video right now. The only Java they know about here is back in their break room. So they follow the directions as they understand them. They go into the break room, they get their cups of Java, and they come back on out and pour them on their workstations. They poured on the Java. Now, Java deals a lot with the Java beans, like some of the packages that you'll import and stuff of that nature. But yeah, we got funny names of computer programming languages. This is Java. So let's take a look at some things we should know about Java too. It's a mid-level intermediate language. Mid-level as opposed to like low-level being super machine-oriented and high-level being very user-oriented. And this is in between. This is kind of in the middle. It's cross-platform, even the compiled work. It's a semi-compiled language, so it compiles for a virtual machine, and that virtual machine is designed to run to cater to whichever platform it's running on. So the compiled executable that will, well, not really executable, the compiled .class file that it will produce is it's compatible with the virtual machine, and the virtual machine focuses on the compatibility with your specific operating system and your specific processor architecture. So it follows one standard, and your compiled work, whether you wrote it on Linux and moved it over to Windows, or compiled it on Windows, moved it over to Linux, that same class file does not need to be recompiled. It will continue to work. So it's semi-compiled. It compiles into that virtual machine based executable, so to say, that doesn't self-execute. All right, so it does a lot of pre-compilation. Now it's very powerful. It's used in many program types, and yeah, I mentioned that before. And it uses the standard curly brace block format. So if you've already worked with C or C++ or PHP, or actually most of the languages out there these days, a lot of this is going to seem just too familiar for you. It's got great encapsulation, great organization capabilities. My biggest thing that I don't really like about it is that it's just a semi-compiled. So you have to go through the process of compiling it when you're done writing your changes, and then you have to still call the virtual machine up to run your code. So it's kind of the worst of both worlds on that aspect of it taking extra time to get going. But it's powerful. It's got access to so many different libraries, it's not even funny. So it's extremely useful for that little bit of... I've got a few things to nitpick about it, but those are some of those. So let's take a look and see some sample code up in here. This is a pretty big file on here, and we're going to go over this. I'm going to tear this thing apart piece by piece. This has been run over here, so it's going to correspond with this output. So I'm going to take this apart and explain different things about this file. So Java is a funny one. You got to have everything inside of classes. I mean, I thought C was bad, that you had to have it all inside functions, couldn't have loose code. I mean, here we can have comments, we can have package declarations and imports, and just, we don't have a lot though that we can put outside as far as real code that's going to run. It not only has to be in a function, it also has to be in a class, which also helps out the organization. I think that's what they decided to do, why they did that. So each class also has to be in its own file. It is enforced by the compiler that it's got to be, and actually it produces different class files as well. So if I produced more than one class, it will produce, if I produced more than one .java file, because I needed more than one class, I would need to have a second file named with that class. So because this class is Java, if I wanted to have a different class, my class, for example, one called my class, I'd have to have a myclass.java file separate. I couldn't put them both in the same. They won't let me. It'll fail on the compilation. So you've got to have that. You've got to have this class right here. And it's got to match. And then inside there, it's looking for whichever one you're going to be able to run. To be able to run this class file, you have to have public static void, and I'm going to explain this, main, and then your args. So what it's doing with public, it means, and I will go back over these moderators a little bit, modifiers a little bit further down the line. But this means that it's able to be got from outside the class. And public on the class means I can get it from outside the package if I'm working within a package, if I created a package, which I could have if I wanted to, but I wasn't really creating all that. But I have this code here, I can say package and declare which package this is in. And then this class would be a part of that package. So if I wanted to build some other program later on that imported my package, did this import thing to the my package, then I would have that, this would be accessible. This would be an accessible class. If I made this private, it would not be, and I think this has to be public in order to be able to support my public void over here. So it's got to have something that the outside world, because I think that's what it's trying to do, is it's trying to say the outside world's calling that. For that to happen, it's got to be public. Now, static means that I don't, now public means it's accessible in this class. This means that this is a member, and this is accessible within this class to things outside the class. That public does. That's different than this public. A class defines an object. And a class can have all these other, it can inherit other classes, it can implement additional interfaces, which those are just commented there just to show. These are comments, by the way. Single line comment and multi-line comment. This starts with a // with a /* and then it ends with a */. And that formation is how I remember it. It's just kind of like it's boxing in a bunch of stars. So that created, all of that is a part of the comment because of the outside. So these are single line comments, what I just did up here. I'm not actually creating a package, I'm just explaining how that's done. I can also import from the Java libraries, which I do, and I will be discussing that shortly after all this. So yeah, static now at this point means, this is one of the things that's really funky with Java. Java can have members of its class. I know .NET, Microsoft .NET also does some of this too. But we can run certain methods on these classes, those that are marked static, can be run without instantating the class. Later on in the code here, I'm going to create the class, and that's when the constructor is called. But I have all this other stuff that's been running in the class the whole time, but it's not actually running in the class. You know, I have the class constructor called way down there at the end when I actually instantate it. All of this stuff is all going to be running before I even create an instance. So only that function is there simply to organize where it is. That's what that's for. Now, restrictions of a static means I cannot access any other members that are not static on this class. I can access private things, but they must be static. If I'm trying to access variables that are like a core part of the class, like say if I had a variable right up in here that was actually attached directly to the class, I couldn't access that. The compiler will say, no, you're trying to access stuff that's not static from a static function. And it's just going to say, nope. So, because it's not going to be instantated when this is run. To run this, I can just, yeah. So, that's kind of how it handles, in a sense, it's loose code. Void means it does not return a value, and main is a name that it's actually going to look for. It is, I mean, this class needs to be in that file. Whatever name you call that file, this class needs to match it. This class name .java. It's not the class name .the class name. It's the class name .java. So it's going to look for this method. It's going to look for that void on that class. I'm sorry, it's going to look for that main. Void main. It's going to look for a main that does not return a value and takes in a string array. Now this string array is, whenever I run this, if I had added additional parameters on here, if I went ahead and typed in on after that Java, this is the Java virtual machine that I called, and then this is my class name. but I didn't have to enter the dot class after that because it's actually running the executable. I already compiled it for this. So this is running the executable on here. The compile command would be javac java.class, because that's the code file. I'm sorry, Java, I'm sorry, because that's the code file. But to call a class file is going to be up here. But if I had entered anything else after that, if I'd entered a space and entered some other values, those other values, as they're separated by spaces, would be elements of this array. So I could access them within my code and find out what parameters did I give my program before I started it. So it's going to start this function, and it's going to, it's going to get us started. So we're going to take a look. This is a basic input-output example that was done right in here. So I've created a string, and in this case we're going to see two different system out prints. This is a bunch of system functions. Now this is for the output, and on there's a function called print, and now I'm passing it. Now this is not print L. Down here I have a print L. This means print with a line drop on the end of it. This means I'm not going to put the line drop. This gave me a prompt and left the cursor right there in front of it and allowed me to type in something, and that's where I got my Java scanner that scans for inputs. And I told it to get me my new line. I created a class, because you've got to create the class there, and then I got the new line into that string. Took my scanner instance. So this is defining a type, defines the type for the scanner, and then this is my name of my variable. I'm going to go new, creating a new instance of that class, and this is a class I'm creating, and I passed it a parameter, which is the system in class that it's going to use to read from. So I could pass it other things that could be inputs as well, other streams if I wanted to, if I can get access to those and process those. In this case I'm processing the CLI input. I got a whole line from here. From the scanner I got the next line and put that in my string. This function returns my string. And now system out print line. So once I entered that, because in order for it to take the new line I had to push enter, and that's going to be echoed on there. So that's going to be the end of my first line. We can see prompt, it stopped my cursor there, I typed in test, then it comes on over here, and now I entered, that's a string literal right here with the double quotes, plus is a concation operator, and puts two strings together, puts my variable string right here, so I'm putting all that together for my output now. So I entered space whatever I typed in. I typed in test, you entered space test. And then it dropped down the line because that was the one that had the line drop. The other one did not. That's why I left the cursor there, and now this one dropped it down because that's the print line. So that is a basic example of input and output. We've seen comments. I've talked a little bit about imports and classes. We're going to cover that a little bit further later on with our classes. First of all, I'm going to take a look here at some rudimentary variables. What types of variables can we run on? Actually, we are going to take a look at better than that. All right. And a lot of things can also be referenced on these guys. Yeah. So booleans are just one bit, true or false. You got bytes, shorts that are two bytes, really shorter version of an int, of an integer. That's what that means. It's an abbreviation for integer. So integer 4 bytes, long integer 8 bytes. This is how many bytes they have to represent the number. So the larger the number, the more bytes there are. So how much memory are you allocating to that when you declare something? And we're going to show some declarations further down on how this works a little bit better. But this is just kind of setting up the idea on what types of variables can we create in Java. Now most of these, this is the 8 core types up here between boolean and character. Now string it's actually a class. It's actually but it's oftentimes looked at as the 9th type because it's everything loves to use the string. It's used so widely that it's so widely supported and so easily supported. It's like in the language syntax. You use the plus operator like I showed you up there. Use the plus to put the strings together. All kinds of different things. Now, this is just a true or false. These guys are all for whole numbers. These guys are for decimals. And these guys are for text. You can also define an enumeration, just like I defined an enum right here, with different options. Arrays, which are that's where you can have several of the same type of variable as one variable. So we're just going to I do create one later on, I think, on here. Actually, one is passed as well in, but I think I actually work with one later on. So we got strings, so this would be an array. So array argv, and if you use the square bracket, kind of like these guys are, it's exactly like those guys are. If I moved those over here in my code, 0 would be my first arg returned, my first argument sent. 1 would be my second argument sent. So all of the same type. In that case, I created one of type int. Could have done anything. Could have been byte. As you'll see, I love lots of bytes on here. I've got a lot of examples with that. A lot of things are references. A lot of times you can pass a reference to objects and all kinds of stuff, but that's another type that you have. You've also got null. You've also got true and false, as we showed up here, true or false for boolean. Null means it's not referencing anything. And there's also void that we've seen. That's not really a type either. That's just something that is used to say that it won't return a value. So, all right, we've talked about null. Typecasting. If you are going up in the type, if you're going to something that can definitely handle everything that it was plus some, I'm taking a byte and I'm taking it to a short. I'm trying to call a function. I have a byte that I've already declared out here. I'm using one of these byte variables, and I'm trying to call a function that takes a short. It won't have any trouble. It will automatically take that typecast. Now, if I'm trying to do things the other way around, and I'm trying to have a byte where a short is needed, then what I'm going to need to do is I'm going to need to typecast. That means I need to put this parenthesis byte, whatever type I'm actually turning it into. In this case, I'm using the example of byte. Put my type in parenthesis there, and then the variable name of the larger or whatever won't automatically cast. And then that will return that in that type that I've casted to. It also works if you're dealing with class inheritance, where you need to move it to a more detailed version, to a child type of a class, because a lot of times when the machine runs, it will look for certain members that it knows should be there, and if it doesn't know that member should be there, it will simply just say error, or at least throw you some nasty warnings, and it may or may not work. So by typecasting it, it tells it, yes, I am expecting it to have this member, proceed. So you'll also use that sometimes with classes. You'll run across those times where you'll be like, yeah, I need to use that member, but it's not necessarily there on the type that I'm declaring that it is, because I'm using a derived class. Now I need to typecast that base class into my derived class. I've had to use it that way before. All right, bytes down here. In our case, we show that we can make two different bytes at the same time. So I've defined MyByte1, MyByte2, and assigned them those numbers. Now down here I show I can do a multiple assignment at the same time. I'm setting them now both down to 0. I don't necessarily have to assign the value right away either. I could have just said MyByte1, comma, MyByte2, and then done this. But if it's not been initialized, actually they already have a default value if they're not. I think they default to 0 if they're not already initialized. But it's always good to initialize it and know what you're dealing with. Here I have an incrementation. That means I took MyByte2, and that was 2. Now it's going to become 3. And then I also added, this is the way of adding, this would be the same as saying MyByte2 equals MyByte2 plus 1, or whatever. I can have this be a literal number. I can have this be a variable with a number in there. Whatever works. But by the time I'm done with this, MyByte2 would be equal to 2 again. Even though I took it to 0 here, but I added 1 and added 1. This could be any number that I want to, but this just helps me to add on to it without a whole lot of extra work. Very handy operator. And here we have an array declaration. Okay, this is a multi-dimensional array. So the byte here, I show that I've got 2 dimensions that I'm loading in here, and this is the name of the array, and these curly braces tell me what the values are going to be. So I'm creating, this is my first dimension, and this is my second dimension, and this is what's getting loaded into each of that, into what's getting loaded into my first dimension, both those elements, and what's being loaded into my second dimension. So that's how I can govern how those things are loaded. So I just created and loaded my byte, and we will work with that later on, so that'll become a little bit more clear how we load that, because I have an example on how that spits back out, how I get that back out to the output. Alright, control structures though first, and that's actually in further down on this that I actually go into this. If, else if, and else. This is dealing with the MyByte equals, well, this is the MyByte1, which we know we took it back down to 1, I took it back down to 0, and did not change it since, so it's still 0. So we're checking to see if it's 0, and what do we get on there? It says yes, it is 0. That's what this is for. So yes, that was true, and so it output 0 here. Now this is also true because it's less than or equal to. Now this does not run because this is only if this did not run. This is an else if. So this ran, it's canceling everything else out over here. But if it had been less than 0, it would be printing negative. If it was anything else at that point, none of these other ones had run, it must be positive. So you just used else for that. We could also, there's also the exclamation mark equals, and that is for not, greater than, less than. There's a whole bunch of operators there too that we can choose. And you can even use multiple of them in there. You can put them together with an ampersand, which is for and, or which is 2 pipes, or with an exclamation mark, that's for not. There's a bunch of operators you can use in there to determine your comparisons and how they should end up. So, you know, do I want this to not be equal to? Do I want this to, that's the other way that I could put that, not equal to. You know, these two are not equal to each other, but then I can check to see if they are equal, and then are they not? Bunch of options on there, and then yeah, as you can see over here, less than or equal to, greater than or equal to, and I don't need that equals either. I can just make it, and that would be at that point exclusive of 0, exclusive of the equal. So that's the if. Now we're going to see a shorthand version of if over here, which is why I take my string and I'm going to load it based on an expression. Now when we do this on C, back when C, it actually runs some code. If you've dealt with C on this, I've actually been able to get it to run a command, but here it just has a variable or literal or something like that it will return to this. So yeah, in this case I'm checking my byte to see if it is 0. If it's true, this gets loaded to my string. If it's false, everything after the colon before the semicolon gets loaded to my string. So it's just making a decision based on this. Which of these two guys is it going to load into my string? And then I print that out, which we can see that gives us my next 0. Well, I'm getting a lot of zeros today, aren't I? All right. So that's where we printed that out. That was what gave us that other 0 I highlighted. Now we're going to take a look at switch. And once again, we're going to use myByte 1, and we're going to see if we're going to test it to see if it is 0. And we can add as many of these blocks in there as we want to. I can sit here and say, I want to check it for 1, check it for 2, and then check it for else. That's the point behind this structure. So it's going to see, does this equal this? And then it just goes through all of the options until finally, if it doesn't match any of those, then it goes down to default. But if it does, then we're going to break out of that. We're going to do what we need to do for it, which is say it was 0, and break on out. Without breaking out, then it continues to go down and check for anything else. And I think it would even run the default as well. Default runs unless you've broken out of it. So it would be printing 0 and non-zero, which would be a little bit confusing. In our case, it just printed 0, and we broke out. There's also a continue command, which is useful in loops, which we're about to get into down here, which will bypass one iteration of that loop. But if we did break, it would break out of the entire loop completely. So here we go to the first 4, and then after the next 4, we're going to revisit that array that I told us that we were going to revisit. On this 4, this is a very standard type across all the curly brace format. I've actually seen that they just all use the same. It's like, I don't know, they all got it from the same. I think they all got it from C. But here they are. You declare in your first set, you have a for loop. And when it first runs, it only runs this on the first time. I'm declaring a byte variable with that name, and these are all accessible in the scope of these parentheses and through the curly braces and the parentheses. So this is my iterator that I'm planning on using, and I've assigned it to 2. And so that's where I'm going to start counting. And it's going to run as long as this, as it checks, it's going to run and it's going to check to see if the second argument is if its condition is true. It's comparing that. It's looking for an expression. Is this greater than? Then I continue. If this is false, I break out. And then, not on the first time, but between each and every one of my other iterations, it will run this. So this allows for me to, this is a decrement operator for that iterator variable. So I'm counting backwards is what I'm doing, counting backwards by 1. I could set this up to do whatever I wanted it to. I could have it count by 5s if I wanted it to, count up, count down, divide in half, whatever. My options are endless with this type of loop. So it's just comparing here to see if it's still running. And in here it's going to keep printing on each line my for iterator. So let's take a look and see how that worked. So we started off at 2, it ran that, then it decremented as it came back around, gave me 1, it ran that, printed that out, and then it decremented again, and it checked that, and it said, oh, nope, because it is not, it is not equal to, it's greater than, yes, but it is not equal to or greater than. So this failed. This is false. And it breaks out of there and continues down here and now tells me, okay, now we're going from for to for each. For each goes through arrays, and that's why I'm going back into visiting my previous array. So we're going to take a look up there a couple times. What we have here is, we can also use a for structure that has a single colon in here. In this case, I have my iterator here, which I'm dealing with a byte array. That's why I want this iterator to be of the type of whatever that array was containing. It was containing a bunch of bytes, because each one of those is going to be passed to each one of them is going to be passed and become this iterator. On each pass, it's going to give me a different one. Now I'm going to get an array, and basically what a nested array is like that is it's an array of arrays, and you can have them as many layers as you want to. But in this case, I am getting the second array, because this is 1. The first one would have been the 0 and the 1. The second one is the 2 and the 3. So that's what we should see. It's going to pass me a byte of 2 on the first pass and a byte of 3 on the second, because I'm only pulling down here, I'm only pulling my second half of that, my second array out of those 2 arrays. So we're going to see a 2 and we're going to see a 3 in here. 2 and 3, because the other 2 were on the other half. And so that's what we did. We just printed them out. So now we're going to be moving on into not a do loop, a while loop. This is a while loop. And so yes, now we're going to be taking a look at while, and that's while this condition is true, it will continue to loop through here. So I want to do something to change this to make sure it does not stay true. Now my byte 1 was set to that 0 way up there, and it wasn't changed. So so that's this one. So it's going to be 0, and then it's going to be 1, and then it will not be less than anymore. It will be equal to, and I didn't say equal to or less than or equal to. I said less than. So 2 doesn't qualify. That's why it breaks out. So we have this in here to keep incrementing. And we need to have something like that in there to keep moving that to make sure it doesn't just stay infinite. Let's take a look down over here at do loops. This just hits the same concept, and we just did it in backwards. While, do while, right up in here. And I brought it backwards as well in the opposite direction. But it just moves, by putting do up here, we can then put the while clause down here, which means now it's comparing on the exit. It's going to run that at least once. and it's going to compare on the exit. So just in case that little technicality is worth something to you, then you have that option to move that down there with the do while syntax. It's very, very similar to the while loop. Now we're going to take a look at exceptions. This is how we handle our errors in Java. And it's the typical try, catch, and yes, it does have finally available to it as well. So finally runs no matter what. Try is where we can have an exception thrown either by a function that we will call, or we can throw our exception if we're just trying to jam things up ourselves. Whoops, didn't mean to drag that. So yeah, I mean, we can throw something in there. Hopefully it's a legitimate error, not just trying to jam things up, but that's one way that we can say, hey, I've got a problem, and we're checking for that problem. So in the try, we are checking for that problem. As soon as that problem occurs, nothing below that is executed in the try. It's then going to go to catch and execute whatever's there. If no exception is thrown, it will just run the try, and then once it's done with the whatever it's going to do in the try and whatever it's going to do in the catch, it's then going to run finally, and then it will exit. So that's the way a try block works. And I can throw whatever exception is available. Anything that extends throwable in Java. So whenever you're ready to throw a fit about something not being right in your code, you know, the condition not being right, just pick up anything that's throwable and throw it, right? Okay. Functions. This is going to be another one too. And I did mention those modifiers, which we're going to take a look at that a little bit more onto here. But here I can say on my function down here, here are my sample functions. There's a couple things to look at. And I'll take a look at the constructor down here in a little bit. But these two, you'll notice that these two critters have the exact same name as each other. One just doesn't have any arguments, and the other one has an argument. It's not worrying, though, that I have a void and I have a byte over here. It does matter that they are static and that they are callable. And being that this is my same class, private will not prevent me from calling it, because I'm calling it from within the class. So even though I'm calling it using the class's reference like this, Java function, actually in this case here I'm actually calling the first one anyway. But yeah, so that's how I would call these functions. Let me try and see if I can get them both in view. No, I can't quite fit them. So these are written right off the class, because that's what this critter is for. This is the end of my class, and so these are right there under the class. They are not going to be written in the main code. And so it's going to depend on whether or not I throw it a byte, whatever I throw it something on in here. Being that both of these were empty calls, it knows it's going to be returning nothing at all. But here I have the opportunity to return something here. So these have to be static because I'm calling them from a static function. It's not expecting that there's an instance running of that class. The compiler is not expecting that, and so therefore it expects that I'm going to call things that don't require an instance of that class, and static ensures that. And so it does support function overloading. That's what I'm trying to demonstrate here, is it does support function overloading. And so there's a couple ways which I can call it. I can call it just straight, and I can also call it by calling it by the class name, because it's got that static function. Now, if I was trying to call this within, I could use this to call it. this is a reference to the existing class I'm coding in. However, I better not have any references to this because that means the instance of the class. And being that I'm working in the static, in a static function here, I cannot call anything that deals with an instance like that. So I can call it kind of using the outside calling through the backdoor type thing. So we've also got some modifiers. I'll look at that shortly after I'm done talking about classes as well. That way we got something to talk about. Now, classes can be instantated. In this case, I'm actually going to be instantating this very class, this Java class. I'm going to be instantating this. So that means the name of the class, the name of the type, which is Java. That's why, is because I know it's a little bit confusing because I'm working in the Java language, but this is the Java class. Java refers to my class type, and that's the same thing as up here. This is the class that I'm working in. So if my class was my class, I would have to type my class in that place. It would be my class in here as well. But in this case, I'm using my class for the instance. That's the name of the instance. That's a variable I'm going to assign it to. And I'm assigning it to a new instance of my Java type, my Java class. Calling this constructor without arguments, which is fine because I have a constructor down here and I can overload my constructor. And when you're overloading two, you can have some be public and some be private. You can mix and match. Those are options that you can use as well. But whenever this calls, you'll see the constructor has been called. Entering classes, constructor called. So I've been working in this class the whole time, and it was never calling the constructor. Now that I actually instantate it, that's when the constructor gets called. And then here I'm setting it to null. And that was to demonstrate to the unreliability of a destructor. At one point I had a destructor in here and I'm not sure where I put it. But a finalize function that you can write in there is for a destructor. But it's very unreliable in Java because you don't determine when things end. The Java virtual machine has a thread that does the cleanup on a regular basis and cleans things up. So, yeah, let's take a look here. And so, yeah, that was where, yeah, that's the class I was going to mention. And then we exit and then return. This was a void main. We didn't return an int with this, which is kind of unusual for a lot of these types of programs. Most of them return 1 because 0 is supposed to mean no problems. Anything else is an error code. In this case, they don't care. They don't return anything. They're looking for a void. Now, let's take a look at our modifiers. Modifiers for class. Public means you can access it outside of your package. So if you did create that package and something else imported your package, could they access that class? Only if it says it's public. If you don't enter anything there, it defaults to not being accessible outside of your package. A final class cannot be changed. It cannot be, it's particularly to avoid it from being able to be turned into a child class. You're not allowed to, if the class is declared final, it has a final modifier, which the modifiers were up here where I put public. That's the modifiers. So if one of those, and that these are the member modifiers. Actually, these two are member modifiers. But this is the class modifier. So that's what we're talking about down here. So, yeah. Public means it's accessible to others. That means if you try to extend the class, you cannot extend anything which is final. That means cannot be inherited by anything else. So you can't write a child class for it later on. Abstract is kind of like an interface. Here, it means that you're not going to be able to instantate that class. You must inherit it, and you also must inherit any of the abstract members which don't need bodies on those members. You can just, like, say on these functions, they would end with a semicolon here, and you would have no body down there. It wouldn't have that return those curly braces. It would just have a semicolon on the end if it was declared as abstract. And that's particularly for, you'll see, for the member abstract on that, if the member is declared abstract. But this declares the class that you can't instantate it, you can only extend it. So for child class, you just have to put that extends whatever class name, and this would go here. After that Java, then you type that extends space extends space whatever class name. And then you can also, you have the option of implements, and there you can use multiple interfaces. But for there, you have to implement all of everything that's in that interface. Now, the point behind doing this is to give, like, say, if you're going to pass something to a function, let's say I want to have, instead of passing a byte down here to this function, maybe I want to pass a certain class, and I want to know that it's got certain members, so, but I don't really care which class I get, as long as I have my required members. I'm going to write an interface and say, give me something with that interface. That class cannot implement that interface. It cannot work to be passed to that unless it has all of the criteria that I'm expecting. So I can feel free to work around with my function and know it's got all the members it's supposed to have. Whether or not they're doing what they're supposed to be doing, that's something for the future. But all right, let's take a look at members. Members, public. You can access them outside your class. Protected, you can access them through derived classes. And private, you can't access it outside the outside of your you can't access it outside your class at all. Not even a child derived class can access it. Final is something that can't be changed. You can't override it. Don't try and override it in a child class. Don't try to change it. That's a great way to be able to make a constant. If you want to create a variable and declare it final, that means it can't be changed. Static, that's where it's able to run without being instantated, but it also cannot interact with other things that require instantation. Abstract, that means it's missing the body, it's got the semicolon, and you have to on any other class that's going to be derived from that, it has to be implemented to be instantated, to be able to have an instance created of it. Instance means it's creating a new copy of itself, like what I did down here. So transient means it's going to be missed on the serialization. Synchronized means it's only going to be allowing one entry. Like, say, if you got multi-threaded stuff, only one thread can access that member at a time. That's particularly for functions. Only one thread at a time can access that, so other ones that are trying to access that at the same time will be halted until they'll be queued to access it. So it makes it to where you don't have the same function being called multiple times at the same time. If there is a concern with that, you can mark it as synchronized, and then it can't be called multiple times at the same time. And last thing, we have volatile, which means it's going to be using not the thread's memory for that. It's going to be in the main heap. The main memory is where it's going to be using for keeping track of things for it. These are, I think I've pretty well, yeah, and so I discussed this too. And these can be private, protected, public on these constructors. It needs to be the name of the class. Whatever class it is, the name does not need a return type. It already knows there's no return type. You can add members to it, but this is how you can call it, and this is how you can set something up too. So I could put parameters on in here, and you can overload any function, including the constructors. So I can have one that sets it up empty, and I can have another one that has parameters that sets it up however I want. So that's the code for Java. And now we're just going to take a quick look at commands. Yes, Java compiler, Java C compiler, that's going to be for the name of the full name at that point of your Java source file, and then it will compile that. And if you've got a really good compiler too, then it will look at other references to other classes that you may have created and automatically compile those as well. But don't count on that. Make sure those classes are created. And yeah, so that's one item. And then once you're done compiling it, then you would then go on into running the virtual machine, which is just Java without the C and space, and then that's just the name of the class, and there you don't need the dot class. It would be Java dot class, but it already knows that. So that just launches a virtual machine. It starts, it tries to find that main function that's the start of where the program runs, and it goes from there. And once that main function is allowed to exit, then your program exits and gives you back a prompt if you're on the command line or whatever it be. So that's Java for you in a nutshell, the core basis.
Thank you for watching.